the universe. Let's get right into it.
Now, to truly appreciate our first masterpiece, we really have to grasp the mind-bending scale we're dealing with here. NASA uses this incredibly striking analogy: a single grain of sand held at arm's length against the sky. So imagine taking one tiny grain of sand, holding it out at arm's length, and just looking at the tiny speck it covers against the vast night sky. That incredibly tiny slice of space is literally all we're looking at in our first image. Yet, as you'll see in a second, that infinitesimal speck holds thousands of entire galaxies. It's wild. So here's our map for today's gallery tour. We're exploring the cosmic deep fields, a galactic cosmic dance, the stellar nursery mountains, a dying star's rings, and finally, signatures of alien water. It's the ultimate cinematic story of cosmic life and death.
All right, stepping right into Room 1, the cosmic deep field, specifically SMACS 0723. This first visual masterpiece is located a staggering 4.6 billion light years away from Earth. That means the light captured right here has been traveling through the dark, empty void of space for 4.6 billion years before finally hitting the telescope's sensors. We're literally looking back in time. And to get a deep field image anywhere near this, the famous Hubble Space Telescope had to stare at a single patch of sky for weeks, just slowly gathering enough light. But Webb captured an exponentially sharper, more detailed image in just 12.5 hours, using its near and mid-infrared cameras. It really shows how our ability to gather data has become drastically more efficient. It's just a massive technological leap in visual capture.
Now, if you look closely at the edges here, you'll notice some of these galaxies look kind of stretched or smeared into circular arcs. This is an amazing visual phenomenon called gravitational lensing. Basically, the SMACS 0723 cluster in the foreground has such an immense, overwhelming mass that its gravity literally warps the fabric of space around it. It acts exactly like a giant cosmic magnifying glass, bending and amplifying the light of even older, fainter galaxies that are hidden far behind it. And because of that magnifying effect, combined with Webb's near-infrared spectrograph, we can look further back than ever before. 13.8 billion years. That's the estimated age of our universe. Because space is expanding faster than the speed of light, the light from those earliest galaxies gets stretched out as it travels toward us, shifting from visible light into infrared. By capturing those stretched infrared waves, we are quite literally seeing the infancy of the universe. We're observing galaxies that formed just after the universe was born. Unbelievable, right?
Okay, moving right along to Room 2, Stephan's Quintet, a galactic cosmic dance. We're transitioning now over to the Pegasus constellation. Now, this isn't just one quick snapshot. It's a sprawling, chaotic visual mosaic constructed from exactly 1,000 separate image files carefully stitched together. It is a breathtaking, wide-angle cinematic shot of the cosmos in absolute motion. And while the name Quintet implies a tight group of 5, our eyes are actually playing a little 3D trick on us. One of them, NGC 7320, is much closer to us, sitting about 40 million light years away in the foreground. The other 4, though, they're a massive 290 million light years away. And those 4 are the real story. They're locked in this violent, gravitational cosmic dance, pulling, stretching, and physically colliding with one another. Webb allows us to clearly see how these collisions compress gas and spark the explosive birth of millions of new stars.
But the really crucial point is what's hiding right at the center of the topmost galaxy in that group, NGC 7319. Thanks to Webb peering through the dust, we can see it harbors an actively feeding, supermassive black hole. And guys, it is an absolute monster. We're talking 24 million times the mass of our own sun. As it violently pulls in surrounding cosmic fuel, it heats up the material to extreme temperatures, radiating outward with the blinding light of 40 billion suns.
Next up, welcome to Room 3, the Carina Nebula, also known as the Stellar Nursery Mountains. To really ground you in the cinematic scale of this visual masterpiece, those towering, glowing mountains of golden dust and gas, they aren't just hills. They are an awe-inspiring 7 light years tall. Just think about that for a second. If you started at the bottom and traveled at the absolute speed limit of the universe, the speed of light,
it would still take you 7 full years just to reach the summit.
Located 7,600 light-years away, this whole region is just a cauldron of intense, chaotic energy. Webb's infrared cameras are uniquely capable of piercing right through the thick, opaque dust that completely blocked older telescopes. And it reveals a landscape carved out by intense heat and blistering ultraviolet radiation coming from massive, young stars just off camera. This radiation pushes against the gas and dust, and where the pressure gets to be too high, the material actually collapses in on itself to ignite and birth brand new stars right before our very eyes. All right, stepping into room 4, the Southern Ring Nebula, a dying star's rings. To understand what we're looking at here, we first need to define the term planetary nebula. And look, despite the confusing name, let's be honest, astronomers aren't always great at naming things. It has absolutely nothing to do with planets. A planetary nebula is actually an expanding shell of glowing gas and dust expelled by a dying star in its final stages. The star has basically exhausted its nuclear fuel and is violently puffing off its outer layers into the cold vacuum of space, creating this absolutely mesmerizing ring effect.
Now, for years, when Hubble looked at the center of this nebula, it only saw a single bright star. But Webb's incredibly sensitive mid-infrared instrument peeled back that thick cosmic dust to reveal a dramatic secret. There's actually a second, dimmer star, cloaked in dust, locked in a tight orbital dance with the brighter one. And it turns out it's actually this dimmer, dying star that's responsible for ejecting all of this material.
If you look closely at the edges of the nebula, you can see these distinct, rippling layers. Astronomers count at least 8 distinct layers of dust. Because those 2 central stars are locked in a tight, swirling orbit, they act a lot like a cosmic sprinkler system, sculpting the dying star's ejected material outward in waves. Each of those 8 layers represents a completely different epoch, giving scientists a visual, thousands of years long history of this star's death throes. It's like reading the rings of a tree, but on a cosmic scale. Finally, we enter room 5, exoplanet WASP 96b, signatures of alien water. So WASP 96b is a pretty extreme world. It has about half the mass of our Jupiter, but it orbits incredibly close to its host star. A full year on this planet takes just 3.5 Earth days. And because it's so close, the temperatures are searing, reaching nearly 1,000 degrees Fahrenheit. So yeah, definitely leave your winter coats at home for this one. Now, Hubble first found water on an exoplanet back in 2013, but that was after years of trying. Webb, its instruments are so ridiculously precise that it clearly detected the signatures of water vapor in the atmosphere of this planet on its very first attempt. Let me walk you through exactly how Webb actually pulls this off using what's called the elegant transit method. Over a 64-hour observation period, Webb just watched the star. In step 1, the exoplanet passes directly in front of the star, creating a tiny little shadow. Step 2, a tiny fraction of that starlight passes perfectly through the edges of the planet's atmosphere. Then in step 3, the chemical molecules in the atmosphere, in this case water, or H2O, absorb specific wavelengths of that light. And finally, in step 4, Webb captures that filtered light, measuring exactly which colors are missing. Think of the resulting graph just like you would forensic evidence at a crime scene. Every single molecule in the universe, whether it's carbon dioxide, methane, or water, absorbs light in a completely unique pattern, exactly like a human fingerprint. Those fluctuating dips and peaks you see perfectly match the known fingerprint of H2O. It's undeniable mathematical visual proof of alien water floating in a sky over 1,000 light years away from us. Which brings us to the end of our gallery tour today, and it leaves us with an incredibly profound thought. These 5 stunning masterpieces, from the deep field showing the dawn of time to the fingerprints of water on distant worlds, were essentially just the telescope warming up. Seriously, these were its first images. So if this is just the beginning of our new visual reality, what staggering, universe-altering wonders is the James Webb Space Telescope going to reveal to us next? Thank you so much for exploring this cosmic gallery with me, and as always, keep your curiosity focused on the stars.